Solving compound inequalities, there's two different types. There's an AND type and an OR type. Okay, in an AND type, what's happening is your variable's going to be sandwiched between an upper and lower limiting value. So the AND type of inequality would look something like this. If you're solving an AND inequality, your solution set is going to be bunched together. It's going to be a lower limit to an upper limit, and that's it. It's going to be grouped together in there. So your AND, when you're completing or solving an AND inequality, you need to isolate the variable from the middle of your expression. And the way that you isolate that is you undo each part of this, but you have to undo it to all three parts. So again, if you think of this being three different parts, and you have to undo the operations to all three parts. So to isolate this x in the middle, we first need to isolate the term. So we undo the adding 1. And to undo that, we have to undo it to all three parts of this inequality. So that's going to create a new expression. Negative 3 is less than negative 3x, which is less than 9. Okay, we still haven't completely isolated our variable, so we have to undo any other operations. So it's being multiplied by negative 3, so to undo that, we're going to divide everything by a negative 3. So we get 1, we get our x, and we get a negative 3. And now, what happens to inequality symbols when you multiply or divide by negative? You have to switch them. So this less than symbol needs to switch to greater than, also here. And so when you're writing these, I always want you to write your expressions with the smallest number to the left, largest number to the right. So is 1 smaller than negative 3? No, so I need to switch all of these around. So I'm going to write my 3, or my negative 3, then my x, and then my 1. And then just align your inequality symbols based on the direction. So with comparison to the 1, the inequality symbol is opening to the 1. So when I rewrite it here, I need to open it to the 1. My inequality symbol here has the point pointing to the negative 3. So I need to have the point pointing to the negative 3 when I rewrite it. So here would be my inequality form for this expression. Or that if I wanted to rewrite this in interval notation, what's my lowest limit? Negative 3. My upper limit is 1. Is negative 3 included in this solution set? No. So it's a parentheses. And how about the 1? No. So it's also a parentheses. So this is my interval notation for that. All right, let's take one more example, and I'll show this next example on the calculator. And we'll come back and talk about ORs here in just a second. But what if I gave you the following inequality? All right, if you're going to use your calculator for this, right, we can still go to our solve feature. Okay, type in the equation, the inequality exactly as it appears. Now, here's a shortcut. Okay, you can express less than or equal to by either doing a less than, so second function 0, and then followed by an equal to, just like how I had you enter some of those answers. Okay, or if you'd rather use the shortcut for this, and it's not labeled on your key on the keys, but if you use the green diamond and then the less than, so the 0, it gives less than or equal to as the individual symbol. So you can do it that way as well if you want to save just a little bit of time. So green diamond, less than, gives you less than or equal if you want to solve for x. And we can enter this whole problem in one solve statement. Hit enter, and it'll give us our answer. So the answer is given as negative 5 is less than or equal to x, which is less than or equal to 1. And now you'd simply need to translate this into the inequality, or the interval notation. So our lower limit is negative 5, our upper limit of 1, are there going to be brackets or parentheses around these? So here we have the equality, the equal to. So again, the easy way to think of that is you just draw in your equal sign, spread it out a little bit, but then connect a vertical bar. So you have a bracket, we have equal to here, so again, a bracket. So that's what our interval notation would look like here.